Howdy, this is Rajesh. Welcome to Apidays, Melbourne 2023. Today I'm going to talk about navigating the evolution of API platforms, sync and async communication pattern. Passively, every one of us actually contributed to the evolution of API platform and the way how we communicate between systems and to our things, right, from our client applications. Let's talk through the evolution of API first. So in my own terms, I tend to actually divide this into three phases. One is legacy phase, where we all developed probably we call it as web services. I call it as a legacy pattern, mostly because of we used ESBs and other technologies to expose our services. And back in the days, we don't tend to call it as API. We tend to call it as web services. Predominantly, we used SOAP XML to expose our services, expose our data to our consumer. The consuming applications are mostly the desktops because the mobile was not very relevant back in the days. And then comes the microservice era. Microservice era was changed a little bit more, where the way how the things are consumed between B2B and B2C. Predominantly, it was using REST and JSON. And B2C actually took precedence, in my opinion, a lot. It changed the way how we communicate with the companies, with the businesses, and the payload size has changed quite a lot. Evidently, from SOAP XML and REST over JSON actually become a bigger play in the whole communication between services and between the consuming applications like mobile applications and things. If you notice, the difference between the legacy era and microservice era, the devices started to get much more smaller. We don't actually do business just with our desktops, our laptops. We tend to actually the devices started to got much more smaller, like mobile devices. And then comes a next gen. I haven't named it yet, but I tend to call it as a next gen, where our consumer devices got much more smaller, like wearables, watches, and other things. And the protocols changed quite a lot. When I say protocol, I'm talking about transport protocols. The protocols changed, and the way how the B2Bs and B2C businesses actually also changed heavily. Now the data, this is more, I would call it as a more of a data era. We got abundant data flowing through across the internet, and the way how we are trying to figure out is how we can optimize the way how we can transform the data from one consumer to another producer and vice versa. So here we are seeing a much more newer protocols like gRPCs and the MQTT and other new protocols are coming and helping, so that much more smaller devices are connecting to each other or to the systems in the place. To start with, that's the evolution which I'm seeing and where it is going through. So now about me, as I said, I'm Rajesh Bavanantham. I've been in the industry for last 23 years, I would say, still going. So predominantly my experience actually comes from API, developing integration services and security. I don't want to go on to a complete memory lane for all the 23 years. So I'm just going to talk about last few of my gigs. Let me start with Australia Post, the one which I really enjoyed. Worked there as a solution architect, where I actually involved in setting up the API platform and identity platforms for Australia Post. Later, out of Australia Post, I did a small stint with Kong. It was one of the early days of Kong, where I worked as an architect, where I involved with a lot of customers. This is where I started to meet a lot of customers outside of Australia. So I meet hundreds and hundreds of customers across the world. After Kong, I moved on to Nginx. Nginx was acquired by FI Networks. So I ran a product management team over there. I played multiple roles, but predominantly the product management team, where I ran a product management team where we actually build API platforms, security platforms, and other sorts of anything related to the API side. It was really a good stint around Nginx and FI. And then currently I'm with MLC Insurance, working as a principal architect, and it's going. Enough about me. So let's talk about the agenda, what we are going to look today. So the agenda is not big. I just wanted to shorten it into like a 4 different categories, but there are a lot of content. There are a lot of lessons what I have learned in last, decade with a lot of customers I spent across the globe, spent the time across the globe. The agenda more we are going to talk about what's synchronous and asynchronous communication. What's the difference between these two, and what are the approaches I have seen for synchronous implementation. What's the approaches I have seen for asynchronous approaches, and I also wanted to talk about the difference between message and events. So this is kind of a concept I always wanted to talk to the customers when I was with Kong and Nginx, because there's always a bit of a difference and a bit of a misunderstanding between these two concepts. So now let's deep dive onto the topic. So synchronous versus asynchronous. As you all know, the synchronous communication, it's more about a real-time interaction where the consumer is actually trying to talk to the producer without any delay. It is purely a tightly coupled integration between the client and the producer. It follows a very traditional request response model, where the client sends the request and the server sends the response immediately without any avoid. The example of implementing synchronous applications or RESTful APIs, as you can see, it's been there for a while, and GraphQL and WebSockets. So around this, there are a lot of patterns also actually came through. The patterns actually started to talk about, when I say patterns, I'm talking about the specification, how to actually build the structure around the RESTful APIs or GraphQL or WebSocket. So there are few options it came around. One is a Swagger or OpenAPI spec, as you would have used at the time of developing the REST APIs. And the GraphQL has got its own specification, how to define a GraphQL construct within the one. And WSDL, as you can say, it's kind of, I don't see that being pronounced quite a lot, but for SOAP APIs, you tend to still use WSDL as a contract where you specify how your contract should look like. And the RAML used to be there at some point, but I think it is heavily used by MuleSoft these days. And JSON schema is widely used as compared to Swagger as well. I have also captured on the left-hand side, you can see from a Postman state from the report for 2023, what's the heavily used specification. As you can see, that JSON schema is pretty much topping in the list, and then comes the Swagger and the OpenAPI. So we have a list of specifications that is being used. There are some specifications, to be honest, I have not come across. For example, Avro. I don't want to go too deep into that, but there are a number of specifications across synchronous communication. It's been there in the wild. Let's talk about asynchronous communication. So the asynchronous communication is more about when a client is not expecting a real-time data, real-time response from the producer. So it's more of think of like a fire and forget. A fire and forget is more about, I'm calling you, so you don't have to respond back to me, but you do your process and you come back to that one. In a subsequent slides, I will talk about how this is being implemented, how this is being, in a different way, it has been realized by different customers. There are multiple ways of doing this. So either use messages or events where you actually have, instead of getting a direct response, the asynchronous API actually uses, an eventual response back from the consumer, from the producer to the consumer, or sometimes you don't even have to send a response. So that's why we call it fire and forget. There are specifications even for asynchronous communications. As you can see, there are Async API, which you can refer to. That's where it is trying to solve to put certain level of constraint. It is equivalent to the Open API or a Swagger, as you would have seen in the REST world. And there is another thing which is really, really popular these days. Is one of them is called a cloud events. In my opinion, I think these two specs should come into one. The reason why I'm actually making this is there's a lot of commonality between these two, but also there is a bit of a difference between these two as well. So I see very good things on both things, and maybe it's a time for them to actually think about what's the best way of merging this into a single specification. But that could be another reason why they never wanted to do that. But these are all the specification for asynchronous API in place. On the left-hand side, again, if you have to jump, you can see that, again, thank you to the Postman. they actually did the state of report for 2023. You can see the way how the synchronous and asynchronous communication is being used in the wild. As usual, REST actually tops the list. REST has been heavily used. It is proven for last decade. So it's been heavily used, and surprisingly, webhooks is actually getting there. And SOAP is slowly, every year it is going down. The usage is going down, but still there is a place for SOAP because most of the legacy applications or legacy systems, which is still going strong, completely based on SOAP. So let's actually jump on to a few of the examples or a few of the patterns what I have seen customers using across the globe. So first, let's start with the synchronous pattern. So this is a very simple and a working pattern where customers actually have a web application and have a API gateway component, which they try to integrate with their backend services, right? Sometimes they use, so I have seen customers using API Gateway as a composition where they use API Gateway to compose the response from the backend microservices and send a response back to the client. And sometimes they actually have a composition services sitting in between the API Gateway and the microservices. So the composition services, or even some customers tend to call it as a facade. They tend to actually compose the backend responses from the other microservices and send the response back to the API Gateway. So in this particular pattern, the request and response is pretty much in a synchronous mode, which means the consuming application is expecting the response to be played immediately or within agreed SLA time. So this is heavily used. This is, if anyone is starting their API journey, this is exactly where they would start. They will start with a REST API where they actually go and do a synchronous service pattern where they can actually bring the data or expose the services to the front-end application or to their partners. Asynchronous. So asynchronous, this pattern I have seen with many customers where they do not expect the response to be sent to the consuming applications immediately, or even sometimes they actually tend to do this as a more of a fire and forget. So I've seen a couple of patterns. I kind of coupled this within a single slide where they use API Gateway to do a schema validation, where they do a schema validation and do a bit of a business logic check, because there are a lot of API gateways which can let you to do a bit of a customization on the gateway where you can apply certain condition check on the payload, what is coming in. So you can do a schema validation and you can actually do certain logic, business logic behind the gateway, which I'm not a huge fan of, but still there are a lot of customers actually doing that. And from the API gateway, they tend to drop that message into one of their queue system or in an event system, and then respond back to the caller saying that thank you for the business. Sometimes they have a validation service away from the API gateway. They tend to do that kind of a validation outside of the API gateway and drop the message into the event bus or even in the message broker. So from that point onwards, what happens is the microservice tend to actually pick those messages and they tend to do the processing based on that. Since the contract is verified at the edge, the microservices tend to go on to do their job, whatever the jobs to be done for each one of the microservices. They tend to pick it up and they tend to process that one. So this is a little riskier, but when you have a proper contract maintained between your client and the producer, this is a best way of actually implementing your fault tolerant and other aspect of actually managing the services with a high availability, which means from a consumer point of view, a business is always on, and from a backend, from a producer point of view, they can actually work on the services whenever the services are available for them, so that they don't have to worry about responding to the client immediately. It is not simple as it looked like. So I just wanted to double click on it. When I actually worked with a lot of customers, I wanted to actually see how they really actually trying to manage those fault tolerance, and how are they actually handling those exceptions. So if I have to double click on that, so this is how it would look like for a single service. I just took a one flow with the service. So if you have to look at the right side, you can see that there could be an upstream legacy backend. It could be a database, or it could be a old service. So it may not be available all the time. So the microservice, what it tend to do is when the validation service drop the message into the event bus or into the message one of the queue, then the microservice actually tend to pick that message and try to call the backend. If the backend is not available, then microservice needs to be coded. One of the microservice needs to be coded to actually set a counter and the expiry to that particular message and put that back into the retry queue. On expiry, there is a way you can rely on the brokers, the queue brokers, to actually push that message into the rail queue or the main queue. In this particular case, since the microservice have set the expiry message and the counter to set to 3 times or 5 times, again it becomes available into the main queue. Again, the microservice can actually go and pick it up and then reset the counter by from 3 to 2 or 5 to 4, whatever counts they are actually setting it up, and then again they can keep trying with the backstream. So since they have a counter there, they can actually retry that number of times by managing that from that microservice. So the microservice takes a bit of an infrastructure work as well to make sure that they are processing that number of times. So this particular one works really, really well for a lot of customers I have seen, because of the way how they have structured, and they have elegantly, they're managing the messages between multiple queues. When the counter actually reaches 0 and they are not able to, still if the backend legacy backend is down, they can choose to put that into the dead letter queue. The dead letter queue can be alerted to the support team. Support team can actually start to do their support work, whether when they can actually bring that to the main queue or actually fixing the backend. All those things can be quite easily handled. So if you look at the previous ones, are talking about multiple service, imagine you have hundreds of microservices, and this is the one pattern which I have seen. It's a bit of an infrastructure work, but once it's set up, the framework is set up, it is really, really working well for quite a lot of customers. So let's talk about asynchronous pattern. So what we talked about all the time now is more about when customers from external factor, they're calling from a browser or from a mobile app, how it is being handled. But it is also a similar case when a service to service communication happen. A lot of customers have seen they are moving away from a synchronous communication between a service calling and another service through HTTP call. Instead, more and more adoption, I'm seeing that moving towards message/events way of doing it. Whether they use a message broker or an event bus to actually go and do processing. So this is a very simple form, again, a simple form of actually representing when an order processing actually happening. Order will actually come from anywhere it can come. It can come from external, or it come from an internal one due to another process. It kicks it off. That order processing can drop the message or event into the queue, and there are two services which is listening to that queue system. One is invoice processing, the other one is payment processing. So it depends on how it is actually processing, how do the fault is actually handled. Everything goes successful, then it is fine. Then if there is a problem happens, how it solves, it's also it depends on how they structured the infrastructure for the message and the events, similar to what I just showed in the previous screen. So again, I wanted to double click on it. It's even though it looks so simple, it's not that simple. It still need a bit of a work how it has to be properly done. So this is known as a saga pattern from a synchronous point of view. This is heavily used by a lot of companies. Actually, as a matter of fact, Amazon uses this heavily, which I will come back to that in a minute. But as you can see, that order processing, when it actually fire a message or an event to a topic, and a message or event will be subscribed on the invoice processing microservice, as well as at the payment processing. If any of this actually fails, let's talk about the failed scenario next. If it is successful, then it can actually send a response back to a topic where the order processing can go and commit it, which means if you're ordering a book, it can actually pretty much says that, yes, I have done the invoice, yes, I have done the payment, all good. You can finalize the ordering, which means you can go and do the rest of the things. What's the final step of the ordering? So pretty much this is a mimic of a acknowledgement of the the request response model by sending an acknowledgement back to the caller. So the way how this has been done, even though this sounds like a synchronous, but the way how it is structured is to make sure that it's been completely decoupled, the way how you process the message between those services. That means the invoice processing or the payment processing service doesn't have to be always online. So you can eventually process those things and do that bit. how did this actually you might have seen this particular pattern with when you're trying to order something with Amazon. If you're trying to order a book, or if you're trying to order anything else, if you might have actually registered your credit card with Amazon, and when your order processing is happening, payment processing, we wouldn't know, the Amazon service wouldn't know, especially the order processing wouldn't know that whether you have enough money to buy that. So initially what they would do is they will go and they will try to do each one of them, but eventually they will come back and actually say that you don't have enough money, you have to update the credit card. So they don't actually immediately do that because it is not synchronously managed. Eventually what happens is, through this method, they go and process every one of them. When there is a failure happens, they don't do a full commit. Instead, they come back with an error message saying that you have to fix this. So this pattern, for a very long time, I thought for a retail business, it is very, very hard to do the synchronous pattern, but it is coming more and more. The business is actually changing the way how they are operating and making sure that they're eventually sending the response back to the consumer saying that what they can achieve or what they can't achieve in the way how they do business with them. So we saw a few examples between synchronous and asynchronous. How would you choose between asynchronous and synchronous? I'm going to give a very architect response. It depends. So as I have seen, just to revisit what we just talked before, is for synchronous, it is very ideal for the scenario where you need an immediate response to your consumer, real-time updates, real-time data that needs to be translated back to your front-end applications. So like final still transactions. That if that is the use case for you, then synchronous is the way to go. But imagine this, if when the synchronous actually comes with the cost, because scalability is not a easy way of actually doing that, and availability becomes a bit more problem as well, depends on how your infrastructure is set for. But if your integration is well, that requires an immediate and a tightly coupled communication, synchronous communication is the way to go. Having a REST API or a GraphQL or something is the way to go and do that. But when it comes to asynchronous, as we just discussed, if your real-time response is not critical to the business, if business says that it's okay, we can actually deal this and keep updating the customer eventually, is okay for the business, then asynchronous is the way to go. It is also asynchronous. I'm not only talking about external facing, it also about internal. In the internal facing, if you're actually exchanging a document, exchanging information between system to a system, which doesn't have to be in a real time, then asynchronous pattern is a way to go. So again, as I said, it totally depends on your business use case. If your business demands that your interaction has to be real time, if the data has to be real time, then you don't have a way of actually going to an asynchronous. You have to use the synchronous pattern for that aspect. So let's talk about a few of the synchronous implementation approaches, right? So there are four categories. There are multiple, to be honest, but I have chosen four, which is heavily used, which I have seen across in the wild with a lot of customers. One of them is RESTful API. I don't want to go too much into it because I'm sure you are all exposed to that side of the world very much. It's very much the characteristics of a RESTful API is more about driving everything through resources and HTTP method. So based on an HTTP method, your operations are executed. In a GraphQL is becoming really relevant these days. I'm seeing a lot of read only or more read optimized websites actually trying to use GraphQL. It'll have a single endpoint where you can connect it to multiple systems on the back end where you can fetch the data. This is a very client-driven architecture where client would say what type of a data I wanted to be fetched from a specific data. So the GraphQL middleware can help you out to go and integrate with the backend systems and bring the right information. So you don't have to have a composition services or a facade service sitting behind the API gateway to do that. So the GraphQL middleware can actually go and do that for you. It's a really, really good for real-time updates. The other one which I see heavily being used is WebSockets. So it's purely, it establishes a persistent connection between the client and the server. And once the request is actually made, the connection will be kept persistent, and the updates will be sent from the server block the client in an eventual manner whenever it is ready. The next one, what I see it's being heavily used is gRPC. It's not in an order, to be honest. It totally depends. Depends on which part of the problem you are working on. gRPC, I always thought that it is never going to be kickoff on the client side of the world. But when I say client, I'm talking about browsers and mobile, but I am starting to see that is also being broken. So in a good way. I've seen. Well, I met a couple of customers back in Japan. One of the big telecom company. They are trying to use gRPC as their client side way of actually communicating through an API with the backend, purely because the number of transactions they are actually having, and how they are actually bringing back the response back to the client applications. So even for them, JSON is heavy. They believe that gRPC is seems to be much more lightweighter, and it is much more easier to actually bring those data from the backend to the client side applications. Actually, from a gRPC perspective, I would say that gRPC has got a few aspects to that. There are four, as you can see on the screen. There are unity type, server streaming, client streaming, and bidirectional. So it totally depends on how you are actually expecting your client application and your server to do with. But the difference is here, the unity is pretty much similar to the RESTful APIs, where you actually do a request response. It's one request and a response. But in the client streaming, it's more about you can send multiple requests to the server, and server will accumulate those requests, and then at final end of the request to stream, it can actually send a one response back. And in the server streaming, it is about a client would send a single request, but server will choose to send the responses in more of a packets, more in a streamed way back to the client. And also the bidirectional streaming is more about both client and the server seems to sending the request and responses in an eventual basis, where they keep streaming the request and response at the same time. So that I actually see quite heavily used. I always thought gRPC is going to be really popular in internal service communication, but I'm starting to see that it is actually also getting out of client server model as well. So asynchronous, we talked about asynchronous. What are the approaches available? So here again, I'm trying to summarize to four categories here. One of the we talked about message queues, which is predominantly used for even before the microservice era. Queue was heavily used. I have seen queues actually used even for a synchronous response, because most of the message broker actually supports the request response model, where you actually send a request and you can actually send a acknowledgement back in the response queue. So that I have seen even before microservice era, the people have used that kind of a model where it lies the to communicate between the backend system. So it was even before the microservice era. It was quite heavily used. It's good for scalable. It's good for scalability and for a guaranteed delivery, right? And then comes the PubSub. It's more about how you actually communicate to a topic way of doing it, and then there are multiple subscribers to that one. So that's what I talked about that in a previous section, giving you an Amazon example, where you can actually have a message or an event when a subscribers can actually pick the data, and they can choose to do what they really wanted to do, what jobs to be done. So webhook is also becoming really, really popular, as I just shown you in the Postman collection. The Postman report. Webhook is actually really coming well, because the way how it works is they send the request and pretty much register with their client URL saying that whenever you're ready, come back to me. So that actually helps in a lot of aspect, where when you have a long running process happening, once that long running process happens on the back end, the server can choose to send the response or make a call back to the client whenever it's ready. So the webhook is seems to be really, really getting popular, as you can see in the report of Postman. The event streaming, as I said, there are a lot of examples. I would say Kafka's and Kinesis and Swallows. Those guys are actually doing a great job around that side, and we become pretty much the async APIs and the cloud events, which I talked about. Those specifications are all being driven through that particular one. I'm hoping that this particular section will grow a lot in the coming days. So I just wanted to finalize my talk with the difference between the message and events. I have seen a lot of customers actually use this pretty much like meaning same thing, but unfortunately it is not same. The message and events are completely two different things. I've given an example here as well, like for example, how a message would look like, how an event would look like. To give a very clear distinction between a message and an event, the message will dictate you what is intended to be done. It's clearly, it will have a clear sender and the recipient, and it'll have exactly what needs to be done from the message. So it will be actioned. The message will be actioned straight away. But in the events, it's a little opposite to that one. It actually broadcasts it, doesn't always say that, okay, this is what has happened. It will say that this has happened and during another process. So that's the difference between the message and the events. It can be broadcast. The events can be broadcasted to multiple parties, and the multiple subscribers can pick those, and they can action how they wanted to go and do it. For example, a person entering is an action. Based on that can be emitted as an event to multiple devices. For example, you can switch on the TV, you can switch on the lights. Those are all the events. The entering a room itself is an event. It's not a message. A message, as you can see on the top of the screen, it actually has all the information about what has happened and what are the things it needs to be updated. And example of event actually looks a little different. It actually clearly says that what actually happened. A new content was published by this XXY person. So this kind of things is actually heavily used in MQTT and other event streaming side of the world. I just wanted most of people to aware of the difference between message and events. It's not the same. I just wanted to conclude with this one. It's almost time here. Thank you very much for the opportunity. If you would like to talk more, please reach me out. I'm available on the LinkedIn. It's very easy to search with my full name. Thank you.